All right, welcome back everyone. Some slight technical difficulties, so we're gonna lump the rest of extrapolation in with r squared. And so we left off talking about this extrapolation principle and why then for this example we actually shouldn't interpret the intercept because we're extrapolating. So I'll give you a moment to pause the video to read this quote from Stephen Colbert. Okay, and so Stephen Colbert, humor's not for everyone, but he often has this kind of sarcastic type of humor to his show. And so what he did here is actually extrapolate this increase in temperature out to August. And if you do that, then you would calculate that the temperature by August would be 220 degrees Fahrenheit, which is obviously ridiculous. We could see in our example, if we predict the course evaluation for a professor with an attractiveness of 20, I'm just grabbing that fitted equation that we've been using a lot now, plugging in 20 for x, we get 5.22. So take a second to pause this and think about what's wrong with that prediction. So there are a couple things you could have said. So the main one that has to do with extrapolation is that 20 is outside the range of our data. So we are extrapolating. Something that's then kind of an outcome of this is that we get a rating prediction that doesn't really make sense because ratings only go up to 5. Okay. So basically when we have a regression analysis, we just have to keep this in mind that we shouldn't be extrapolating because we don't really know for sure what's going to happen on this past these points, and we don't know what's going to happen past these points because we don't have any data over there. So it's a little bit dangerous. Living on the edge, but not in a good way. And so that leads into this topic about r squared. It's a little bit disconnected actually from extrapolation, but we're going to define it first as just our correlation coefficient. So that's what we originally introduced when we were exploring our scatter plots.